Okay, in this particular video, we are going to learn the types of organic reagents. The organic reagents can be broadly classified into three types that are: first one is free radicals, second one is electrophiles, and the third one is nucleophiles here. So we are going to study about the each types of reagents here. The first one is the free radicals. So what are free radicals? The species which contain the single electron or an unpaired electron is called as free radicals. So how are these free radicals produced? The free radicals are produced by means of homolytic fission. As we know that there are two types of fissions. One is homolytic, the other one is heterolytic fission. As the name suggests, homolytic means during the cleavage or during the breaking of the bond which is shared in between these two atoms, the A and B, the covalent bond during this breakage, each one of the atoms share a single electron. So in homolytic cleavage, one of the electrons of the shared pair goes with each of the bonded atoms during the cleavage. So thus, the movement of the single electron takes place instead of an electron pair in the homolytic fission. So this movement you can see is being shown by a fish hooked arrow, that means half-edged arrow, as we can see here. That means only one of the electrons is being shifted to each of the atoms here. So each of the atoms is getting a single electron here. So these are what are called as free radicals. Just for but during the heterolytic cleavage, the bonded pair, that means the electron pair which is shared by the covalent bond in between the two atoms, goes to only one of the atoms. So the bonded pair of electrons during the heterolytic fission goes to only one of the atoms, that is heterolytic fission, and that is the difference in between the homolytic and heterolytic fission. So the free radicals are produced by homolytic fission, and the free radicals thus produced are highly reactive and short-lived, which means that it's very unstable and undergoes the chemical reaction. So what are the examples of this? Free radicals. The free radicals examples are, we can see the first type are atoms like Cl, H, or O with an unpaired electron on them. We can see here the unpaired electrons here. And the second type are neutral species like NO, that is nitric oxide, or NO2 or nitrogen dioxide. These are neutral species and which have an unpaired electron. So we can see the Lewis dot structures of these following species. We can see this nitric oxide. So how many valence electrons are there in this NO? So the configuration of N by its atomic number, what's atomic number of N? 7, okay? So 1 is 2, 2 is 2, and 2p3, which means that the outermost shell has 5 electrons. So we can see there's 5 electrons here, and the oxygen, its atomic number is 8. Its configuration is 1 is 2, 2 is 2, 2p4. So outermost electronic configuration, outermost shell, it has 6 electrons. So it is the total number of valence electrons in NO is 11 electrons. So by its Lewis dot structure, we can see that how many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So one unpaired electron is there, which makes it highly reactive, and thus it's a example comes under the free radicals. And NO2, the same thing here. The total number of the valence electron is 17 here. So outermost shell N has 5 electrons, and oxygen, there are the 2 oxygens here. two atoms of oxygen, so 12 electrons, there's 17 electrons, and there's a single unpaired electron. As we can see here is nitrogen dioxide. Again, this is an example of free radicals. So so these are the examples of free radicals. And the second type of organic reagents is electrophiles. So what do you mean by electrophiles? Files, as the name suggests, means seeking. So seeking. So electrophiles means electron seeking agents or electron deficient species. So it's deficient of electrons, so it wants the electrons. So it reacts with electron rich compounds. Okay, so it's seeking, it wants electrons, it's deficient of electrons, so it gets attracted towards the electron rich compounds. So how these electrophiles are represented by E or E plus. So for example of these electrophiles are first type are positively charged ions or cations like hydronium ion, that's H3O plus, Cl plus chloronium ion, bromonium ion, or R plus, which are called as alkyl carbocations or alkyl carbonium ions. So the second type are octet incomplete compounds like BF3, boron trifluoride, aluminum trichloride, FeCl3, or SO3. Let's just read about BF3 here to understand it in a better way. So when we see the electronic configuration of BF3, so boron, it's 1s2, 2s2, and 2p1. So its atomic number is 5. So the outermost electrons are 3 here, okay, 3. And the fluorine we can say is 9 atomic number. So 1s2, 2s2, 2p5. So 7 electrons in the outermost shell. So there's 3 fluorine atoms here. The valence electrons are 24. When you count them, it's 24 here. And we can see that the boron has only 6 electrons. So it's deficient of electrons. How many electrons? It's deficient of 2 electrons. So it's octet incomplete. So central atom, so which is B here, accepts the electrons to satisfy the octet rule. So the central atom is deficient of electrons. It wants electrons, so it's electron seeking. So it's an electrophile, as the name suggests. So this comes under neutral compounds here. So there's a neutral compounds BF3, and the same way this AlCl3 here, it's again 24 electrons, valence electrons is again short of electrons. To complete its octet rule, to satisfy the octet rule, the aluminium here, the central atom accepts the electron, so it's an electrophile. So what are Lewis acids? Lewis acids are octet incomplete. It accepts the electrons like electrophiles. So all electrophiles are Lewis acids. That completes electrophiles. And the third category, we come to the nucleophiles here. Again, as the name suggests, philes means seeking, nucleophiles means nucleus seeking agents or attracts the nucleus. So, or it wants to go to the positively charged centers, which means that it reacts with the positively charged centers. Or in other words, they are electron-rich compounds, which means that if they're electron-rich, they can donate the electrons to the other substances. So as they're electron-rich, they react with the positively charged centers. And again, represented by Nu or Nu minus. There it is, electrophiles are represented by E or E plus. See, Nu minus here, the minus means it's electron rich here. Just if you remember this Nu minus, we can say that it's electron rich. E plus means deficient of electrons. Examples of this are negatively charged ions or anions, which is Cl minus, Br minus, I minus, OH minus, or R minus. These negatively charged alkyl groups are called carbanions. Okay. And the second category of examples we can see here are the neutral molecules like water, ammonia, RNH2, alcohols, that is ROH or ROR. If you see the example of water here, on the central atom, oxygen has two lone pair of electrons and they're octet complete. See the number of electrons here, 1, 2, 3, 4, 2 from this bond and 2 from this bond. So total number of 8 electrons, which is satisfying the octet rule, and they're octet complete, so they can donate the electrons. So they are nucleophiles. And the second one is ammonia, and again there are 8 electrons. One is a lone pair of electrons, and 6 other electrons will come from other 3 bonds that is shared with the H atom here. So again, octet complete. It's a lone pair of electrons on the central atom. So there's a nucleophile, as this can donate, this central atom can donate the electrons. And again, this Lewis spaces or electron pair donors. So all nucleophiles are Lewis bases. Yeah. Thank you. They say recording.